Hello everyone, my name is Mayur Chawda. Today I am going to explain assignment 2 predictive modeling for introduction to data analysis. First one we start with key statistics. So in order to find out the key statistics, we will first move to Jupyter notebook to find out how we gather the statistics for this data set. So here first step is to open the Jupyter notebook, then load the libraries. So we are loading import numpy as a numpy as a np, then import pandas as pd, then import matplotlib py.py plot as plt. So we will be importing numpy, pandas and matplotlib, then import cbond as sns. So in order to find out the all the libraries are loaded, we'll be putting one simple print command of done. So we'll see that all the above code is run and we got the print statement as done. After that, second step is to load the dataset. So as our dataset is a .csv file, so we'll be using .read csv file on pandas. So data is equal to pd.readcsv assignment to weather condition.csv. So in order to print the dataset, we'll be using data.head. So we see the dataset. We are having 5 columns: temperature, humidity, wind speed, visibility, and pressure. So here temperature is the dependent variable on all the 4 independent variables. So as the humidity, wind speed, visibility, and pressure increases or decreases or it changes, temperature behaving according to that. So next step is to find the key statistics. So we have assigning the new name to our data. So data set is equal to data.describe. So .describe function will give all the key statistics about our data set. So we'll print data set. So we have found the all the key statistics as below. First key statistics about our dataset is mean, the average value of dataset variables. So average temperature is 11.93 Celsius for our dataset. Humidity is 0.73. Wind speed is equal to 10.81 km per hour. Visibility is 10.34 km and pressure is 1003.24 millibar. And second key statistic, our minimum value. So minimum value is lowest value of dataset variable. The minimum temperature is given in given dataset is minus 21.82 Celsius. The lowest value of humidity, wind speed, visibility, and pressure are 0 because there is no negative pressure or negative humidity for our dataset. And third point is max. So the highest value of dataset variables. Highest temperature is 39.9 Celsius, humidity is 1, wind speed is 63.85, visibility is 61.16.1 kilometer, and pressure is 1046.38 millibars. Now we'll draw the box plot to visualize our data point. So for that we are using sns.boxplot function. So plt.figures. So figure size is 15 by 10 and sns.boxplot data for data. So we can see the results as below. So temperature box plot, humidity, wind speed, visibility, and pressure. Second analyze we will be doing is for scatter plot. So we'll be drawing temperature versus independent variable scatter plot. So we'll draw temperature versus humidity, temperature versus wind speed, temperature versus humidity, and pressure. So to draw the scatter plots, we'll be using for loop from Python. So plt.figures, figure size is 15 by 20. So we'll set one counter as 1 and we have started the for loop for the columns. So if column is temperature, we'll continue to draw the plot and we'll find out the code. After that, once the second variable is finished, we'll increase the counter by 1. So the variable will move to humidity to wind speed, then wind speed to visibility, and visibility to pressure. So we'll see temperature versus all four graphs here. Next one is regression model. The relationship between one or more independent variable and a response independent or target variable is described by a regression model. So in order to get the dependent variable, we are using independent variables, and for that the model we use is called a regression model. When to use the regression model? So when information about the independent factor is known, forecasting the value of dependent variable or predicting the effect of an independent variable on the dependent variable, we are using a regression model. So there are total 8 types, so 10 types of regression models. First one is linear regression, second one is logistic regression, third is polynomial regression, fourth is ridge regression, fifth is lasso regression, sixth is quantile regression, seven is Bayesian linear regression, eight is principal component regression, ninth is partial least square regression, and last one is elastic led regression. In this dataset, we are dealing only with linear regression. So linear regression is the most often used modeling technique which assumes a linear relationship between a dependent variable y and independent variable x. A regression line, also known as the best fit line, is used. The linear connection is defined as y is equal to c plus m star cross x plus e, where c denotes the intercept, m denotes the slope of the line, and e is the error term. The linear regression model can be simple with only one dependent and independent variable, or complex with multiple dependent or independent variables, or with numerous dependent and numerous independent variables. So coefficient. In regression with multiple independent variables, the coefficient tells you how much the dependent variable is expected to increase when the independent variables increase by 1, holding all the other independent variables constant. Coefficient are the values that increases the indicator values. Suppose we have the following regression equation: y is equal to 2x plus 4. In this equation, plus 2 is the coefficient. So as the x increases, the y will depend on it. X is the predictor and plus 4 is the constant. Now we'll go to Jupyter Notebook to find out how the linear regression we achieved. So for that linear regression, we defined x and y variable. So x is without the temperature. So we will be dropping temperature column from our table. So data dot drop temperature and arrange into numpy array. So x will contain all the columns without temperature and y will contain only temperature. After that, we'll assign the order just into train and test data set. We'll scale the data and print out the unstandardized mean, unstandardized standard deviation, and standardized standard deviation. After that, we'll write the script for linear regression. So for that, we are using sklearn linear regression. We have imported linear regression model and we have imported metrics. So name of our method is linear regression and we'll assign all the variables after that. So for coefficient, we'll be using coefficient table and we'll print out the all the metrics. So MAE, MSE and RMSE. So what is MAE? Model matrix. So M mean absolute error is MAE. It is the measure of errors between paired observations expressing the same phenomenon. The MAE for our data set is 5.68. The MAE is calculating as 1 divided by n. So n will be our total data set value. So summation of 1 to n predicted value minus actual values mode. So we'll use mode to not get the minus value for MAE. After that, mean squared error, MSE. An estimator measure that average of the squares of the errors. That is the average square difference between the estimated value and the actual value. MSE for our dataset is 49.69. It is calculated as MSE is equal to 1 divided by n. So our dataset total value summation 1 to n predicted value minus actual value square. Root mean squared error. So RMSE, it is a frequently used measure of the difference between values predicted by a model or an estimator and the value observed. The RMSE for our dataset is 7.05. RMSE is calculated as square root of 1 divided by total dataset points, summation of 1 to n, yi minus yi bar square. So we can see the results of our linear regression. So we'll print out the method is equal to linear regression. Intercept is 11.90. Humidity, coefficient of humidity, wind speed, visibility and pressure, R square, adjacent R2, mean absolute error, mean squared error, root mean squared. Now final step is forecast table. So in order to predict the temperature, we'll using predict 2 is equal to predict T. So difference is equal to predict 2 minus y test. So we'll give the predict 2 as a new forecast table. So the difference will be the predict 2 minus the y test means our actual results. So fact table is equal to pd dot data frame actual minus predicted minus actual is equal to our difference. So we'll printing forecast table. So for forecast table printing, we'll use dot head function. We can see the forecast table as below. Now, final step, methods to improve the performance of the regression model. So there are total 3 methods here given to increase the performance. So first one is by reviewing identical values. So for example, one may have indistinguishable factors in the dataset, such as mass in kilograms and mass in pound. So here we have 2 mass columns with different entities. So the model will get confused and it will be slowed down as it has identical column names mass. So it will ambiguous name. So we should be avoiding like this type of factors. So second one is limiting of creating independent variables. This way we cannot provide redundant values to the model. So model will not have redundant values. If we create so many independent variables, the model will have so many variables which are dependent. So it will take all the values again and again as it all the values already available in independent variable. So we should be avoid creating so many dependent variables for our data set. And last one is providing adequate data to the model for accuracy. So data set should be large. So for accuracy to increase. For example, if the data set contains only 100 values for accuracy, the accuracy is less. But if we provide more values like 10,000 or more, it will increase the accuracy. Thank you.